Welcome to Chapter 8, the last chapter of first semester. We're going to talk about sequences and series and things that follow a specific pattern. Alright, let's go ahead and get started. To begin with, a sequence is something that follows a specific rule. So for example, something is increasing by the same amount every time, or decreasing by the same amount every time. Our goal for this first section is to identify the pattern for the sequence and try and use that to predict future terms within that pattern. Alright, here's our first example. So we have a formula, a sub n is equal to 3 times n minus 2. A sub n represents the actual term, 3 times n minus 2 is the formula to get that term. So if I wanted to find the first term, I would plug in a 1 from my n value, and what I would get is the first term, a sub 1, is equal to 3 times 1 minus 2. Which is 3 minus 2. If I wanted to find the second term, I do the same thing, plug in a 2 for n, which means that my second term is going to be 3 times 2 minus 2, which is 6 minus 2, or 4. If I wanted to find the third term, we do the same thing, plug in a 3 for n, and I would get 9 minus 2, which is 7. At this point, hopefully you guys recognize that there's a pattern, so I'm increasing by 3 each time. If I wanted to find the fourth term, I would increase by 3 again to get 10. And I could do it one more time to get 13. And I could keep going if I wanted to find terms past the fifth term. Alright, this formula is a little bit more challenging. So we have 1 plus the quantity negative 2 to the nth power. I want you guys to find 3 specific terms. Find the second term, find the fifth term, and find the 10th term by plugging in 2, 5, and 10 for n respectively. Alright, hit pause now and go ahead and try that. Alright, let's go ahead and attempt this. So if I wanted to find the second term, I would plug in a 2 for n, so 1 plus negative 2 to the second, which would give me 1 plus negative 2 squared is 4, so 1 plus 4, and that is 5. Finding my fifth term, I would plug in a 5 for n, so 1 plus the quantity negative 2 to the fifth, which gives me negative 32 plus 1, and that is a negative 31. And finally, if I plug in a 10, then I get 1 plus negative 2 to the 10th. And that's going to give me a positive 1024 plus 1, which is 1025. If you guys had some trouble with this one, I would make sure that we focus on your term within parentheses. So if you have a negative 2, make sure you do put that in parentheses in your calculator and then raise it to the second power. If you just wrote it simply as 1 plus negative 2 to the second without parentheses, you would not get the correct answer. So make sure you're using those parentheses when you have these negative values and exponents. Alright, now we have what is called a recursive sequence. For a recursive sequence, every future term is built off specifically the one that comes before it. And my formula reflects that. So the k plus 1, or the next term, comes off the k term, which is the one that comes before it. So, for example here, if I wanted to find the second term, that's equal to the first term plus the third term. In order to do this though, we have to know what the first term is. So I'm going to go ahead and tell you guys that the first term is going to be 15. If I didn't know the first term, I wouldn't know what to plug in from my first term, and I couldn't find my second term. But now that I know what it is, I can plug it in, and my second term is going to be 15 plus 3, which is 18. If I wanted to find the third term, it's based directly off what the second term was. And so that's going to be 18 plus 3, which is 21. If I go farther out in the sequence and I wanted to find, let's say, the 20th term, then I would have to know what the 19th term was. So the unfortunate part about this formula, or recursive sequence in general, is that you have to find each term in order. We couldn't do what we did for the last example and find the 5th or the 10th term out of sequence. Okay, so I want you guys to use this recursive sequence to find the first 5 terms. I've given you the first one, which means that you only have to find 4 more. Alright, go ahead and give it a try. Okay, so when finding my second term, it is based directly off of what my first term was. So I plug in 3, and I get 2 times 2, which is 4. If I wanted to then find my third term, it's based off of what my second term was, which is 2 times 4 minus 1, which is 2 times 3, or 6. If Going to find my fourth term again. It is based off of what my third term was, which is 2 times 6 minus 1, or 10. And at this point, if you recognize a pattern, we can try and use that. So I increase by 1 to go from 3 to 4, and then by 2 to go from 4 to 6, and then 4. So I'm kind of doubling, which means for the next one, I probably am going to be adding 8. Let's go ahead and check that out to see if that happens. So my fifth term is going to be 2 times my fourth term minus 1, which is 2 times 10 minus 1, which is 2 times 9, or 18. So it does work, which means if I wanted to continue the pattern, instead of adding 8, I would add 16 to get the next term, because I'm doubling what is being added. And I can now use this pattern and not the formula, or if you want to keep using the formula, that's fine as well. Now we're going to review what a factorial is. So a factorial, which is symbolized by this exclamation point, is all the numbers multiplied from that number to 1. Let's go ahead and look at an example. I have 3 factorial, so it's everything between 3 and 1, which means 3 times 2 times 1. And we get 6. Which means that 7 factorial is going to be all the numbers from 7 to 1. So 7 times 2, 7 times 6 times 5 times 4 times 3 times 2 times 1, giving us 5,040. Go ahead and try 5 factorial. Okay, so let's see how we did. 5 factorial is again all the numbers from 5 to 1, so 5 times 4 times 3 times 2 times 1, and we get 120. Let's talk about some complicated factorials and see if we can reduce those. Alright, so here we have some fractions. We have 2 examples here, 5 factorial over 3 factorial, and 7 factorial over 3 factorial. So my suggestion for you guys when you're simplifying these is to go ahead and expand out your numerator. So 5 times 4 times 3. And I'm going to stop whenever I have my denominator. Because at this point, 3 factorial will cancel out for both, and I get simply 5 times 4, which is 20. You can do the same thing for a second example. So 7 times 6 times 5 times 4 times 3, and I can stop there and divide by 3 factorial, because again, those 3 factorials will cancel out, and I get as my final answer 840. Okay, so our last concept to talk about for this section is summation notation. And summation notation just is a different way of writing down that we're adding a bunch of terms together. So this is your summation notation, and it symbolizes that we will be adding all of these terms together. When you're reading summation notation, this a sub I is going to generally be a formula, like what we had when we were finding the term for a sequence. I equaling 1 tells you what to plug in for the first term. So you'll be plugging in a 1 into your variable to find the first term, and the n on the very top tells you when you're stopping. So you're going from 1 to n. It kind of tells you how many terms you're having. And we call that the upper and lower limits. I is just your index. It's kind of like a variable. Don't have to worry too much about it. Alright, let's go ahead and try an example. Okay, so here we have for our formula 3 times I. We're saying that I is going to start at 1, and we keep going until we have gotten to 5. When I write this out, my first term is going to be 3 times 1, because again 1 is where I start, and then we have 3 times 2, 3 times 3, 3 times 4, and 3 times 5. And again, I know I stop at 5 because that is my upper limit. So again, lower limit down at the bottom, upper limit up the top. Now this sigma tells me to add all of them together. That's why I know that I'm adding them in between. If one of the terms was negative, then we would be subtracting it, but you're going to be combining them all. And then we would evaluate this to see what we get as a final answer. And once we have added all these terms together, we get for our final answer 45. Okay, so let's go ahead and try one more example. We have 2 to the k, which again is our formula to find the terms. We're starting when k equals 1, and we're going to keep going until we've gotten to 4. So for first term, we have 2 to the first, plus 2 to the second, plus 2 to the third, plus 2 to the fourth. Now that we have expanded all that out, we'd want to add it together, and When we do, we get a sum of 30. And there you have it, section 8.1. All right, go ahead and open your books and start working on your homework.